Hello everyone, my name is Dr. Rasan Kumar. I am Assistant Professor in the Department of Electronics and Communication Engineering, SR University, Warangal. So today I will talk about the special type of diodes, that is Zener diodes and Schottky diodes. So what is Zener diode? A Zener diode is a special type of PN junction diode that is designed to operate in the reverse breakdown region. So unlike a normal diodes which get damaged in breakdowns, a Zener diode is especially manufactured to the breakdown voltage operated safely in reverse bias. Maintain a constant voltage across it. Because of these properties, Zener diodes are mainly used for a voltage regulation circuit. So basically, so what is the principle of working? When Zener diode is a reverse bias, initially only a small reverse current flow. When reverse bias voltage reach a specific value is called Zener voltage. So breakdown occur, current increases sharply, but the voltage across the diode remain almost constant. This constant voltage make it very useful in electronic circuits. So we can see in that picture the symbol of Zener diode is similar to the normal diode, but the line at the cathode side is bent. This bent line represents control breakdown operations. So there are several applications of Zener diode is voltage regulation circuit, voltage reference circuit over voltage protection, etc. Let us come to the history of history of Zener diode. The concept of Zener breakdown was explained by American physics name is Carlins Melvin Zener. In 1994, he explained the phenomena of the electric field induced in breakdowns in the insulators and semiconductor. This breakdown mechanism was later named as Zener breakdown in his honor. Based on the theoretical work, engineering developed a practical diode that operates in the breakdown region. This device became the known as Zener diode. Although the practical Zener diode were developed later with the advancement in the semiconductor technology. The theoretical foundation was laid to by Zeners. So important point next is operation and construction of Zener diodes. So there are two ways to operate the Zener diodes. One is forward bias region, another is reverse bias region. So mainly students think about Zener diode work only reverse bias, but actually it can also operate in forward bias like a normal diode. Let us understand how. So what happens in forward bias when forward voltage applying to the Zener diode? When Zener diode is forward bias, positive terminal is connected to the P side of the battery and negative terminal is connected to the inside of the battery. The depletion region becomes narrow, barrier potential decreases. As a result, majority carrier across the junction current increases rapidly after the threshold voltage. So we can see the picture when positive terminal is connected to the anode side and negative terminal connected to the cathode side. So forward voltage of Zener diode, in the Zener diode we have exactly like a normal PN junction diode. When applying the forward voltage, then Zener diode we have like a normal diode. For a silicon Zener diode, forward voltage is approximately 0.7 voltage. For germanium it is approximately 0.3 voltage. There is no special Zener effect in forward bias conditions. So what is the IV characteristics in forward bias? The current is very small initially. After threshold voltage, the current increases exponentially. The curve is similar to the normal diode in applying the forward bias voltage. Zener diode not work as a voltage regulator circuit when apply the forward bias voltage to the Zener diodes. So why Zener diode is not used in forward bias? Because in forward bias it's behave like a ordinary diodes. The especially properties of the constant voltage appear only the reverse breakdown. Therefore, practical application use in Zener diode mainly in reverse bias. So next is Zener diode as a reverse bias. When in a reverse bias, positive terminal of the supply battery is connected to the N region and negative terminal is supply batteries is connected to the P region, which is displayed in that figure. So under that condition, the depletion region vents only a small reverse saturation current flow initially. So what happened? Zener diode is special unlike a normal diodes. A Zener diode has heavily doped design with the thin depletion region manufactured to have precise breakdown voltage. This breakdown voltage is called Zener voltage, denoted by Vz. So what is breakdown? When reverse voltage is small, only teeny reverse current flow, the diode we have like a open circuit, but output voltage increases with the input voltage. So there is no regulations occur in this region when operation at breakdown voltage. When reverse voltage reach the Zener voltage, breakdown occur. Reverse current in the breakdowns. When the breakdown occur, reverse current increases sharply. Voltage across the diode remain almost constant. So this is the key properties of Zener diode. Even if the input voltage increases further, the current increases, but the voltage across the Zener diode remain approximately equal to the Zener voltage. This constant voltage behavior make it useful as a voltage regulators. So what is the breakdown mechanism in Zener diodes? So depending upon Zener voltage, if Vz Zener voltage is low below the 5 to 6 volt, breakdown is mainly due to the Zener effect due to quantum tunneling. If Vz is high, breakdown is mainly due to the avalanche effect, that is called impact ionization. That time impact ionization happen in that Zener diodes. In a practical diode, both effects may be present. So, role of series resistance. A series resistance is always connected to the Zener circuit because it limits the current. It prevents damage to the diode. It ensures the safe operation in breakdown region. Without current limiting, the diode may be burned due to the excessive power dissipations. So next is Zener diode characteristics. When forward characteristics is same as the ordinary forward bias junction diode. In a reverse direction, however, there is a very small leakage current between the 0 volt to Zener voltage. When voltage reaches to the breakdown voltage, suddenly current flow through it. So next is uh, IV characteristics of Zener diodes. In, in, in this graph, we observe the IV characteristics of the Zener diode in both forward bias and reverse bias region. Let us understand each point of this graph clearly. So, of the x-axis the graph, the horizontal axis represent voltage, the vertical axis represent current. For right side, that is forward bias region. For left side of the graph, that is reverse bias region. Upward direction, that is forward currents, and downward direction, that is reverse, reverse current. So forward bias region, right side of the graph. On the right side, we see that forward bias region, initially the current is very small. After reaching the cut-in voltage, that is about 0.7 for silicon and 0.3 for germanium, the current increases rapidly. This part looks exactly like a normal diode. So in the forward bias, the Zener diode, we have like a ordinary PN junction diode. So next is reverse bias region, left side of the graph. Now look at the left sides. When a small voltage VR is applied, only a small reverse current flow. This current is very small and nearly constant. This is called reverse leakage region and Zener breakdown region. Now observe the point mark VZ. VZ means Zener voltage. This is Zener voltage. When reverse voltage reach this value, breakdown occur. The reverse current increases sharply, but voltage remain almost constant. This region is called Zener breakdown region. Here the curve become almost vertical. That means the large change in the current and very small change in voltage. This is the important feature of the Zener diode. So Zener diode current limit in the graph you can see IZ minimum, IZ maximum, Zener current minimum, Zener current maximum. This represent the minimum and maximum safe Zener current for proper voltage regulation. So if current exceeds that IZ max, the diode may get damaged due to the overheating. So constant Zener voltage region. In a breakdown region, voltage remain constant at Vz. Current can vary. This property used in a voltage regulator circuit. That's why it is a level as a constant Zener voltage. So what is the important observation of that graph? For what reason we have like a normal diodes, reverse regions. So the sharp breakdown and voltage remain almost constant in breakdown region. And Zener diode is mainly used in reverse bias. So next is Zener breakdown. So in this diagram, we observe the Zener breakdown mechanism inside the PN junction diode. Let us understand each part clearly. Structure in the PN junction, on the left side we have a P-type region, another right side we have a N-type region. Between them there is a very thin region marked a narrow depletion region. Because of this region, Zener diode, it is a heavily doped. Therefore, depletion region is very thin. This thin depletion region is the key for Zener breakdowns. And reverse bias connection at the bottom we can see that the battery in negative terminal is connected to the p-type region, positive terminal is connected to the n-type region. This means diode is operating in reverse bias. When reverse voltage is applied, the electric field cross the depletion region, increase the field becomes extremely strong because of this region is very thin. So ions in depletion region, inside the depletion region on the p side we have a negative ions, and uh, on inside we have a positive ion which is clearly represented in this picture. The ion can create a strong electric field as a reverse voltage increases. This electric field becomes stronger and stronger. So a stronger electric field will pull valence electron from the ions. This is main mechanism of Zener breakdown. Because of depletion region a very thin, even a small increases in reverse voltage create a very instant electric field. This strong electric field pull electrons directly from the valence band. Electrons jump to the conduction band. This process is called quantum tunneling and no collision requirements. So electron tunnel through the energy barriers. So large number of free charge carrier are generated in reverse current increases. Suddenly breakdown occur but voltage across the diode remain almost constant. This constant voltage is called Zener voltage. So important point of this diagram, the depletion region is narrow, heavily doped is present, strong electric field is generated, electrons are pulled by the electric field and break down at the low voltage. So this is Zener diode circuit. When Zener diode is operated as a breakdown Zener region, the voltage across it is constant and large changes in current and operations. The Zener diode is maintained constant voltage across the load despite the change in the load current and or input voltage. As the load current increases, Zener current decreases so that current through the resistance is constant. As the output voltage is equal to input minus and current into resistance. So next is another type of diode is Schottky diodes. So it's a important and a special purpose diode is called Schottky diode. A Schottky diode is a semiconductor diode formed by the junction from a metal and semiconductor. In the PN junction diode, both are PN junction semiconductor, but in this case, Schottky diode, one side is metal, another side is semiconductor. So unlike so p-type and n so normal Schottky diode is formed by joining the metal with the n-type semiconductor material. Because of this metal and semiconductor junction, it is also called Schottky barrier. This means Schottky's come from the German physics Walter H. Schottky, who studies the metal semiconductor barrier. We can see that in the pictures, one side metal, another side n-type materials. So construction now, what is the now construction of Schottky diodes? In normal diode, we have a p-type region and n-type region, but in Schottky diode, instead of p-type metal and thin metal layer such as aluminum, platinum, or any in place of the n type in place of n type semiconductor. When metal and semiconductor are joined, a barrier is formed at the junction. This barrier is called Schottky barrier. The barrier controls the movement of charge carrier. Because there is no p-type material, the Schottky diode does not really a holes for the conduction. It is mainly operate using the majority carrier, which are electron in the n-type semiconductors. Now, working of Schottky diodes. There are two ways to work of Schottky diode. One is forward bias and reverse bias. First, remember the Schottky diode is a metal semiconductor junction diode. Unlike a normal p-n junction diode, it does not have a p-type region. Instead, instead a metal is directly connected to the n-type semiconductor. Because of this structure, it is work only a majority carrier, which are electrons. So in forward bias, the metal side is connected to the positive terminal of the battery and n-type semiconductor side is connected to the negative terminal of the battery. When this is a connection is made, the external voltage reduce the built-in potential barrier at the metal and semiconductor junction. So what happened inside the diode? Initially at the junction, a potential barrier exists. This barrier prevents electron in the n-type regions from moving into the metals. When forward, forward voltage is applied, the applied voltage lower the barrier height. The depletion region become thinner. Electron in n-type semiconductor gain enough energy. This electron cross the barrier and move into the metal. Since only electrons are involved in the conduction and there are no holes participating, the current flowing very quickly. This is why the Schottky diode is called majority carrier diodes. Why is the forward voltage drop low? In a normal silicon diode, the forward drop voltage is about 0.7, but in Schottky diode forward voltage drop only 0.2 to 3. This is because there is no p-n junction. So there is no recombination of electrons and hole at the junction. Only majority carrier movement occur. As a result, energy is required for current conductions. This makes the Schottky diode more efficient and reduce the power loss. So current flow mechanism, so the current in forward bias is due to the thermonic emission of electron over the barriers. So electron movement of from the semiconductor to metal, since there is no charge storage. When the voltage is removed, the diode stops conducting immediately. That's why Schottky diode have a very fast switching speed. So very important point to remember, forward voltage drop voltage is 0.2, 0.3 volt, very fast switching, no minority carrier storage, low power dissipation. Next is working in reverse bias. So reverse bias, metal side is connected to the negative terminal of the battery and n-type side is connected to the positive terminal of the battery. The connection increase the barrier at the metal and semiconductor junction. So what happens inside the diode when connecting the reverse bias? Initially, Schottky diode has a built-in potential barrier at the junction. When reverse voltage is applied, the external voltage increase the barrier height. The depletion region becomes wider. Electrons in the n-type semiconductor are pulled away from the junction. As a result, majority carrier can't cross the junction. Therefore, ideally no current should flow. In reverse, however, a small reverse current flow. This current is reverse leakage current. In a Schottky diode, this leakage current is higher than normal PN junction diode, strongly depend upon temperature, strongly rapid with increasing the reverse voltage. This is happen because of Schottky barrier is lower compared to the PN junction. So in the reverse voltage increases beyond the certain limit, the diode may be enter breakdowns. So Schottky diode usually have lower reverse voltage rating, higher sensitive to breakdown. So that's why they are not mainly used to low voltage application. So important characteristics in reverse bias: higher barrier height, very small conduction, high leakage compared to the PN junction, no magnetic carrier storage. Since the Schottky diode are majority carrier device, there is no reverse recovery time. This makes to extremely fast when switching from the forward to reverse. So, what is the IV characteristics for Schottky diode? The IV characteristics of Schottky diode is almost similar to the PN junction diode. If in case of PN junction, if applied to the forward bias voltage greater than 2 to 3, the the electric current start flowing through the Schottky diode. In a Schottky diode, the reverse saturation current occur at very low voltage and compared to the standard PN junction diode. So application of Schottky diode. Schottky diode are used in general purpose rectifier. Schottky diode are used as a radio frequency amplification. Schottky diodes are widely used in power supply and Schottky diodes are used in direct signals and Schottky diode used as a logical circuit. So this is all about information regarding uh, Zener diode and Schottky diode. Thank you for watching my video.